my name is Fawaz Ghali. I am the head of developer relations at Hazelcast. Essentially, what I wanted today is just to give you a brief description of real-time machine learning and how you can use it for a specific use case for analyzing logs. So it doesn't matter about your background, if you're a data scientist or if you're a software engineer or DevOps, you will get something out of this talk. So I came from the UK, based in Liverpool. Anyone can recognize these guys on the screen? Beatles, yes. So that's where I am from. When I mention stream processing and machine learning in real time, people assume when we talk streaming that we mean music maybe or some kind of TV shows and so on. Essentially, we are describing a type of events where you have to track changes in real time. So this is the key element today where we will need to focus on. So real time means that events arrive in this moment and we need to provide some kind of prediction, some kind of alerts or trends on our data. And this is completely different from traditional machine learning. So we're not talking about building the model. We're kind of like describing how you can deploy it at scale. And essentially what you wanted is some kind of platform that allows you to do real-time machine learning. So most people assume it's easy journey, right? So now if you got your boss might assume that basically you start from a use case and you go straight to results, right? And we all know that that's not the case. Usually when it comes to creating a model and deploying the model, it's not an easy ride. It's kind of like a roller coaster. So what we're looking at is kind of like various challenges that we have to deal with along the way. So how do you package your model, for example? Do you need to kind of have specific deployment configuration on it? How do you scale it up or down? Remember when we talk about real-time machine learning, we actually have kind of like overview how much data we can handle. But obviously at some point, these type of data could have some kind of spikes within it. So for example, Black Friday events or Christmas events or some kind of discount offers and promotions, all this could cause some kind of spikes within your data. Just to make sure that we all understand what real time is, anyone can guess how long it takes for an eye to blink? Any guesses? I can't hear it. Seconds, less, more? Yeah, yes. So we're talking about sub-milliseconds here, okay? So it takes around 1/3 of a second. So this is pretty fast. If you talk about other events, and usually we're talking about real-time machine learning, what we mean by real-time is sub-milliseconds events. So this is pretty fast, and you can actually have some kind of bottlenecks within deployment of your model. Now your question might be, okay, where can I see this type of application? Essentially, it's everywhere. So whether it's finance, banks, sports, for example, or for example, IoT devices, smart devices, or even, for example, medical devices, hospitals, and so on. And obviously today is machine learning. But even if you don't use machine learning in your work, you still need to provide some kind of real-time analytics. So for example, if I ask you now, do you use logs in your development? Yes, no? Yeah, so it's kind of like, you want to provide some kind of prediction how your application is going to perform next. So that's the whole idea. Usually, you can have some tools integrated with this, and essentially, it becomes really bottleneck if you handle large amount of data. And it is challenging because even though we're talking about real time, there are so many elements in this actually, which we want to make sure that we actually integrate. So real-time machine learning actually means you have to combine two different types of data. We're talking about real-time data. This data arrives in this very moment, but also the historical data. So this is batch data stored somewhere on disk or hard drive or in your database. And obviously, we need this. This is very important, which you can't find it everywhere. So many real-time applications miss this type of data because they lose the context data out of it. So what we want is we want to have some kind of platform which you can basically combine the advantages of real-time data as well as the historical data. The historical data we needed to provide some kind of context, how we're doing with the application, And obviously, it depends how much data we handle, right? So in our case, because we're going to analyze logs, so the question becomes how many logs messages we want to handle. So is it like few Ks or few hundred Ks or million Ks or millions or billions? So it becomes really challenging in this case, and especially if you want to scale it, right? Because scaling is a bottleneck for these type of applications. And what you want is not to do it the manual way. So you can't really just write an application to analyze your log and assume it will be straightforward task. And usually scaling is a problem. So the question here, how do you scale your application up or down? And essentially what we're looking for is kind of like two different areas. So one area we mean by providing some kind of alerts. So which means you have a series of log messages and you want to provide some kind of alerts for specific log message or specific level or specific IP address. Doesn't matter what data you use for your log message. Or if you want to define some kind of trend. So how is your application performing over time? Are you using more resources than you expect or less resources? And there are so many tools to use this to analyze these type of problems. Just to make it easy, we split it here into 12 sections. So you have 3 rows and 4 columns. So you can look at it. What we're looking at is the first row and 4th column. So that's the area we're talking about today. So which means you need to do some kind of data capturing. So this is where you capture your log messages. And also you do some kind of transport data, and usually use something like Apache Kafka or Apache Portal, and then you want to do some kind of operation and transformation. So you could use, for example, I don't know, Flink or Spark. And then you can come to the point where you talk about analytics. And to me, it's kind of like overcooking things, because sometimes you use more than one section or more than one square here. And not only that, you might be sitting exactly on the edge, which means you might need tool from number 3 and number 4 at the same time. And we all know it is not easy to do it, because it will add development time, it will add maintenance, it will add cost to your application. So to make it easier for everyone, and just to make sure that we are all on the same page, I can just summarize it in 2 different areas. So one area for the real-time data, where we handle stream processing. So this is data comes in this moment in real time, and we also have the fast data storage. So these tools are good in terms of providing or accessing your data, loading it into memory. So if you want to develop a real-time machine learning application, you probably need 2 or more of these tools. And that's the idea of this talk, to simplify this process and making sure that we are actually using the simplified way of achieving the same results. And that's where Hazacast comes into place. So how many of you heard of Hazacast? Okay, good. That's good. So it's mentioned in previous talks. And essentially, it's a platform for real-time stream processing. So that's the description of the platform, what you can do with it. So on the far left, you can see your sources. Usually, if you work with large-scale applications, you need multiple sources. So your data could be coming, I don't know, from Apache Kafka or Apache Pulsar or IoT device or even messaging queue. Or because it's open source, you can write your own connector to it, or even you can load it in some kind of database connection. So why we need to load multiple data sources to our application in this case? Simply because real-time applications require you to have multiple sources. So for example, if we look at fraud detection, if you want to write an algorithm to detect fraud, you probably need to have multiple sources. So one source could be, I don't know, transactional history. This is one way, one input, and another input could be, I don't know, weather data. So you want weather data to locate the customer where they are located. So if, for example, the customer is based, I don't know, in India, for example, and the weather data is showing like cold temperature, so there is kind of discrepancy between the value and what is expected, so you can flag it as a fraud. And same thing for GPA coordinates. You might want also to consider it for fraud detection algorithm. And you can see here you will end up with multiple sources for your input, for your application. So once you ingest data into Hazelcast, so here you have two options. So first option is the stream processing and machine learning in real time. So you can do some kind of data transform. Obviously, if you want to do some kind of combination between multiple sources, or even like stream processing and machine learning inference, you can do so. But this is just part of the story, right? We're talking about also the other part, the historical data, where it is important for this application because you need to understand what's going for in this context. So if I tell you now your log message has a score from 0 to 100, and you give it a value of 80, for example, what does it mean? So this value by itself, if you get this value into your machine learning model, the value itself, yes, it's coming in real time from Apache Kafka, for example, but it doesn't give you full picture. You still need to go back and check your, I don't know, database or file system to see what 80 means. And that's what the contextual data comes into place. Obviously, you need combination between the two. And it doesn't matter your background. So if you're using Java, the platform is built on Java virtual machine. So there is a Java client for it. But even if you're not Java programmer, you can use C#, or you can use Python, for example, because machine learning, obviously, or you can use Go. And even if you're a data scientist, you can use the SQL. So you can actually do the same query as I will show you today using SQL. So this is very important to understand in terms what you can do. Obviously, when it comes to sending the data out, you could simply send it to another Kafka topic, or you send it to message queue, or even you can send it to your database, or even provide alerts, as I will show you in my demo. Now, the cool thing about this type of applications in real time is how do you scale. Usually when I mention scale, people are split. So some assume scaling means on compute, and some people assume it's scaling on data. It's actually a combination between two. You want to make sure your application is partition aware in terms of compute. What does it mean? It means basically you need to store your compute as close as possible to your data. So because this is where things can make or break your application, because what we're trying to do here is to minimize latency or lower latency. And I show you now how you can implement it, for example, in Python and connect it to Kafka topic. So in this case, you can see I have my data input in Kafka topic A. I ingest it into the platform. I use a method called map using Python, which allows me to connect multiple machine learning models. And from there, obviously, these are stored in batch mode. And then I can do my machine learning scoring algorithm, which is combination of multiple scores. And then I can send it to a sink where I can send the results to different Kafka topic. Now, just to see how it works, if I split my application into different microservices, so you can see here, I can have different topics with different data input from it. So I can connect microservice 1 to topic 0, and then output it to topic 1, and then I can do the same thing for microservice 2 and 3. So again, this is only part of the story, because you still want to understand what's going on with the application and your data. And in this case, we want also to use some data, historical data from batch, and load it into memory in order to actually understand the context of this application. Now, how many of you use Python? Okay, good. So this is the exact area what we want to see how it works if you have multiple models. So you don't need to change your model. So if you already have some models written in Python and you want to basically deploy it on large scale, you can still use Hazelcast to do so. So just to explain this figure here and what it means. So if you have your Kafka topic, you can ingest to different models. So it's the same input. So you can have ingest 1 and ingest 2. So it depends how you want. And this is it's like many to many. So which means you can connect multiple inputs to multiple machine learning models. And you also have the Python VM running, so inside the node, where you can run your model, and it will predict exactly as traditional machine learning model. Obviously, no change here. What will change is how you can actually combine two different types of data. So alongside the Kafka data and Kafka messages events, you still have the other data, batch data within Hazelcast. And this will give you the advantage over Kafka, for example, when it comes to analyzing this type of events. Now, obviously, this is where most people get it wrong. We assume you have data you collect, you have machine learning model, you create a score for it, and then you can basically decide if you're going to have some kind of output or 1 or 0 or rates or trends. But that's not the case when it comes into production. What you need is kind of like a way of combining scores, which means you combine multiple algorithms running on different nodes. Now, how many transactions we're talking about for these type of events? So we managed to run 1 billion transactions just under 30 milliseconds latency on just 45 nodes. So that's really cool. The cool thing about it is the linear scaling, which means you just add more nodes as you have data. You don't want to have logarithmic scaling in your application when it comes to deployment. Now, your question might be, okay, how can I deploy it, right? So because that's what we are here for. So in this case, if you have just one model, what you can do is you connect your Kafka as your source, and you ingest it into Hazelcast, where you can do combination between batch data and real-time data. And if you want to expand it, you can have multiple pods for multiple models. So you can add more models to your application. Now, if you have multiple Kafka topics, you can replicate on different nodes. So you can just repeat exact setup here. And from there, it becomes how you want. So for example, in my case today, I'm using host to do this deployment. In this case, each pod has the Hazelcast instance, as well as the machine learning model inside the host. So this is one way of deploying it. Obviously, you can replicate as many nodes as you want. And the other way is called sidecar, which means basically you have different pods for your machine learning models stored as close as possible to your Hazelcast pod. Or if you don't want to do it this way, you can opt in for the separate farm, so which is like quite common for large scale applications. So you keep your Hazelcast nodes as they are, but you actually have some kind of farm where you store multiple models. So the demo today I wanted to show you is like, because it's like I want you to try it out. I want you to practice how you can do it. So you don't need a machine learning experience. Obviously, if you have, it's a plus. But it's also possible to do it with non-machine learning skills. So essentially what we wanted is to have our log messages. So in this case, I'm using map structure to store my logs. So the key is to have the IP address and timestamp, and the value is up to you, however you want. So in my case, I'm using the port number, for example, log level message. If you want to apply some kind of NLP on your message, or if you want to use a JSON format, for example, or varchar, depends. If you're interested in speed and performance, you need to opt in for varchar. Otherwise, if you're interested in the structure, you can use JSON format for it. And from there, we can carry on to building the model. So the alert, what we wanted is to kind of like having, I think it's a bit hard to read on this screen. So the idea here is to define Hazelcast instance. And from there, you just need to connect your model. So maybe I switch the screen quickly to show you what I mean. Let me just explain the setup first. So I mentioned SQL. So you can run this query. So on the left side of the screen, you can see keys for this map, which is the IP address as well as the timestamp attached. And on the right side, you can see your message and the log score. So in here, what we did is we have this input ingested into Hazelcast, And from there, we define a trend map. In my case, I'm using linear regression, but obviously you can use any machine learning model if you want to use different model for it. And from this trend, I use the trend to build another map, which is the prediction map. So this map will tell me what will happen next based on previous events from my trend. Now I start from my input. So the input could be, for example, a log, for example, log text file or CSV file or Kafka. It depends how you want to send your log messages. And from there, I add the timestamp. I group on the transaction, basically, or the event. And I define the trend. I stored it in a map. And from the map, I use to create another map to do the prediction. Obviously, you need to send the output. So there are various ways to do it. You can send it to Kafka topic, or you can send it to file system, or send it to web application. So let's show you how it works and what you need. Let's just go quickly here. So my predictor, essentially, what you need is, first of all, you need to import Hazelcast into your IDE, whatever IDE. So you can use POM file as I'm doing here. So I'm using Hazelcast here. And essentially, if I go to my code, so the code essentially is just I'm defining my pipeline. So this is where the actual code is going to happen. I'm building this pipeline. I'm reading my probability score for my log messages. I'm defining one instant of Hazelcast, and then I'm attaching this job into Hazelcast. My pipeline, you see it here. I'm using, if you know Java and Lambda function, you can see how you can basically write this code. Obviously, if you're using different programming language, you can do the same thing. So I'm reading from the file. Then I'm using the map journal to create the trend. Obviously, in this case, you can check some values of this trend, and you create something called stream stage, where you can do the score probability. And from there, you check, for example, how you want to split based on your data. So it's up to you how you want to define your input in order to define the trend. And once I define the score probability, I can group on by key. So the key could be related to the IP address for a specific machine, or could be related to specific thread, for example. You can define it. And you can do some kind of aggregation to define the trend. And from there, I'm detecting the linear regression value, and I'm simply checking if the score is greater than 100, flag it or send the alert, otherwise don't. So now if I run it, you will see what happens. So just let me increase the screen here so you can see. And from there, once I run it, you can see the Hazelcast instance is working, and then I have one node defined. And from there, you can see a prediction happening in real time. So this if it is 0, provide me no alert. If it is 1, basically provide an alert. Now, obviously, you don't need to use this for this type of application for machine learning. Any stream application or stream processing application, because you can use same capabilities. So just quickly to show you another example here. So if you want to check the even numbers, for example, you can use the same structure. So I'm reading some source, which is just numbers, and then I'm doing filtering based on the basically a remainder. And from there, I'm filtering just the odd number, which is exactly what we want to do. And here you can see you can use one node for it, and basically it filters out the even numbers in real time. So I realize we're running basically out of time. It's a short. So let's just go back quickly to presentation, how you can proceed from here. And essentially, we look at it from here. So there are 3 options to proceed from here. You can use the SQL create to ingest or read from one map and sync it or send it to another map. You can create a pipeline, and this will have the log messages in store. So first 2 options are batch, And the third option is the real-time, or the map journal, where you can basically do exactly what we did today. Basically, we have a training for this in Bangalore next month. But just to summarize, you need to log your messages somewhere on the cloud. You need to store it in either JSON format or varchar. Depends, and then you need to provide some kind of IMAP structure for random access, rebalancing, and then you need to have some kind of eviction policy in your data. Obviously, you need to consider security. So I mentioned the free training. So this is a free workshop next month here in Bangalore. So take a screenshot. It's a free lunch and then 4 hours training workshop. Basically, you just need to go to this URL, sign up. It will be here physically in Bangalore. So you can check the address as well as make your travel arrangements. And we have large community active online. So if you want to join the community or ask questions, scan this code. You can join the Hazelcast community Slack channel where you can ask questions about what we did today. For example, if you try to replicate the work, obviously you can download the jar file from GitHub. So that should be a straightforward job. And if you have any questions, just let us know. Me and my colleague Raj, can you stand? So we're staying here around. If you have any question for us, feel free to grab us. And with that being said, thanks very much for attending this talk. And I'm open for questions. Thank you.